Hi everyone, this is the first in a series of videos on Pythagoras' Theorem and trigonometry. This is for Year 10 Maths at Alexandra Secondary College in Semester 2, 2024. In this first video, we're going to do a brief recap of Pythagoras' Theorem, and we're going to remind ourselves what this very famous result is all about. So, to set the scene, I need to define a few things. So the first thing I want to talk about is a right angle. So before I get to the right angle, I want to start with talking about a full rotation. So imagine I start at some point, I turn around, and go all the way back. This is 360 degrees, or a full rotation. If, on the other hand, I started somewhere and faced the opposite direction to where I started, this would constitute half of 360, which is 180 degrees. So this is a half rotation. The other thing we could do is halve it again. So imagine I'm facing the front and I turn to the right or turn to the left. This is now a quarter of a full rotation, and this constitutes 90 degrees. And 90 degrees is very common. If you have a table at home, it might have a square shape with edges that meet in straight lines, making like an L shape. That's a quarter rotation. That's 90 degrees. That is a right angle. So a right angle, by definition, is 90 degrees. We are starting a unit on Pythagoras' theorem and trigonometry, and our focus is going to be primarily on right-angled triangles. So what is a right-angled triangle? It's just a triangle with a right angle. So remember, in a triangle, the angles add up to 180 degrees, but one of them is going to be a right angle. So that means one of them is going to be 90 degrees. The 90-degree angle is going to be represented by that little square there. Okay, so wherever you see a little square where two sides meet, that means it's a right angle and it's 90 degrees. And if you know something's a right angle in a triangle, then we can use all the techniques we're going to develop in this topic. The last thing I want to talk about is the hypotenuse. The hypotenuse is simply the longest side of a right-angled triangle. Many of you will be able to see this. In this triangle, the hypotenuse is this side. And I want you to note the relationship between the right angle and the hypotenuse. It's almost facing outwards from that angle. So we could say the hypotenuse is facing outwards from the right angle. Okay, so let's practice. I've given you 4 triangles here, and all we want to do in this video is label the hypotenuse. So I'll give you a moment to maybe pause the video and just have a quick look, see if you can identify which sides are the hypotenuse, and then I'll go through the answers. So hopefully you've thought it through. Here are the answers. The hypotenuse faces outwards from the right angle. Okay, you don't actually need to draw the arrows. I'm just doing that to help you if you're seeing this for the first time. There you go. Okay, let's talk briefly about Pythagoras' theorem. The first time you see this is usually in year 9. By the way, this word theorem, a theorem is basically a major result in mathematics which has been proved. So we know it's true. So, what is this result that's so important that we think high school students should learn? Well, it's the following. If I have a right-angled triangle and I label the sides A, B, and C, and it's important to note that I've defined C to be the hypotenuse. So notice C is the length of the side which is facing outwards from the right angle. So if I label my triangle like this, A for this length here, B for this length, and C for this length, we can write down an equation. So here's the equation. A squared plus B squared equals C squared. And just remember, if you've forgotten, A squared means A times A. B squared means B times B. C squared means C times C. So if I square a number, that means I'm taking that number and I'm multiplying it by itself. So if I take the two shorter sides, A and B, and I square them, and then I add those numbers together, I'm going to get the longer side C squared. It's an amazing result. And it might not be completely obvious why this is true the first time you look at it. So I just want to wrap this video up by showing you a picture that might convince you. But for the rest of this topic, we're basically just going to use this formula and take it as given. Okay, so here's a proof. It's optional, but I think it's nice for you to see it. So here's the idea. Here's a triangle with side lengths labeled A, B, and C. I haven't labeled the right angle, but it's there. And what I've done is I have made 4 copies of it. So here's 1, 2, 3, 4 copies of the same triangle. And notice what happens if I arrange them in this shape. I get a square in the middle. And the length of the square is the length of the hypotenuse in the triangle C. And so the area of this white square on the left is C squared. Okay. Now, I could also rearrange the triangles to make this shape. And now you can see I have made 2 smaller squares, one of them with side length A, and another one with side length B. So the largest square has area a squared, and the smallest square has area b squared. And maybe you see where this is going. The area of the white region is c squared on the left picture, which also equals the combination of the two smaller squares, a squared and b squared here. And the white space in both pictures has to be the same. I haven't lost anything, I've just moved the gray triangles around. So, if c squared is the area of the white space, and a squared plus b squared is also the area of the white space, then I can write down a squared plus b squared equals c squared. And we're done. So that's Pythagoras' theorem. This is a very simple argument to show you why it's true. In the next video, we're going to start using this formula to analyze right-angled triangles. See you then.